Welcome back. This is Minky for exercise 2. For the first question, we are going to find and draw the probability density function of one random variable x and the distribution function. We are informed that x is uniform in A and B, so the density function is equals to, that is 1 over b minus a when x is between a and b. Otherwise, it equals to 0. And the figure is look like this: a, b, 1 over b minus a. And here a might be negative, and this is just one situation. So if a is negative, we could draw like this. They are the same, right? Same figure. So I just draw one figure here. And the distribution function is when x is smaller than a, here is 0. When x is between a and b, here is x minus a and b minus a. When x is larger than b, that is 1. And the figure is, hope I spelled here. So a, b, it equals to 1. Right? The first question is really simple. The second question, we are given the value of a and b and find the density function and distribution function of random variable y. We are given that y equals to x squared. So gx here is equals to x squared equals to y, right? So we could draw the figure firstly, that is gx figure, and a is equals to -1, b is equals to 3. So now we could just discuss y, and y is smaller than 0 or y is larger than 9. The density probability function equals to 0. When y is between 0 and 1, so when y is between 0 and 1, that's a 0 and 1, that is this part, right? So x is look like this. So here we have two roots. Here is 1 y. I just write 1. I just write y here. That is 1x. Sorry, not y. Here that is x2. And 2 roots equals to y to the power of 1 over 2, that is x1. x2 is the negative root. And the derivative of gx is 2 times x. I use the formula that the probability density function of y equals to density function of x over absolute value of gx derivative, that x1 plus another root x2 right? And since a is equals to -1, b is 3, so -1, 3, since y is between 0 and 1, so x is also between 0 and 1. So x is between here, and they are all 1 over 4, so here is 1 over 4. The first rule is this. So we take it to here, so that is this plus the negative root, and it equals to this. Similarly, when y is between 1 and 9, sorry, this should be y. When y is between 1 and 9, so here that is 9. We only have one. Here is 1. Here, this part. So x should be this part. So we only have one root here. And this is the positive root. So we could directly write x1 equals to this. And when, yeah, that is. So the density function is when y is between 0 and 1, it equals to this. And when y is between y and 1 and 9, otherwise that is 0. And the figure is look like this. Here, when y is equals to from 0 to 1, when y is equals to 1, we have 1 over 4. And for this lower limit, here is also we have 1 over 8. Here that is 9. Right. Yes. For the probability distribution function, let me just write the result first, and I'll show you how to get this from the density function. That is from 0 to 1. When y is between 1 and 9, of 1. So how to get distribution function from density function? We could use this. Use integral to get the density function. And let me just write a variable like this. Right. Sorry. Here should be density function. So for example, when y belongs to 1, 0 and 1, it is minus infinity to 0, since there is 0 here, plus from 0 to, let me just write y here. Here y is between 1 and 0, 0 and 1. And we take it here. Let me write p here. Yes, and we could just, this is 0, and we calculate this to get the distribution function equals to that. Right, so this is how we can get this probability distribution function from the density function. And the figure, it looks like this. Here that is 1. When y equals to 1, here is 1/2. Nine. Here that is 1. Yes, we could check. When y equals to 1, here is also 1/2. And then we need to find the expected value of y. So this is equals to from -infinity to infinity y times the density function. And since there are 0 here, we just write from from 0 to 1 y times this plus from y to 9 y times this. This is a piecewise integral. So we just calculate. This is really simple. 1 to 9, and the answer is 7/3. That's it. Thank you.